going to look at lesson 9.2, which is going to be properties of parallelogram part 2. Example 1 here says find the value of variable that makes a quadrilateral a parallelogram along with any other requested value. So basically this is question asking us, well, let's say looking at example A here. Well, what must x, y, and PQ and PR be so my shape here follows all my rules of a parallelogram, which is that opposite sides are congruent, opposite angles are congruent, consecutive angles are 180 degrees, and diagonals bisect each other. So we have to make sure we fill our values that will make these statements stay true. Now let's look at how to find my x here. Now to find my x here, I noticed that right here, that these two, if this, you kind of have to solve this question like this. You imagine it as a parallelogram, and then you kind of solve it. It will be a little bit easier. So if this is a parallelogram, then this means that my PQ here must be the same angle measurement as my SR, because opposite sides of parallelograms are congruent. So let me go ahead and find my x value. So I'll set 3x minus 5 equals 2x plus 1. This will give me, well, I'm going to subtract 2x from both sides. It will give me x left on the left minus 5 equals 1. I add 5 to both sides. This will give me x plus 6. Now, what this number means is if my x is actually 6, if I plug in x equals 6 into these, and these statements will end up equal, then it will not like fail my parallelogram theorems, which is that my opposite sides are congruent. Okay, so with these questions here with A, B, and C, you kind of have to imagine that they are congruent to solve for the variables. Okay, now let's look at the next one for y. Now, the only two expressions that I know for sure is equal to each other with the y included is this one right here, PT and TR. I know that they're congruent because I know the diagonals of a parallelogram bisect each other, which makes, if you don't remember, let's go a little bit back. The diagonals of parallelogram bisect each other, which makes this part right here same as this part. This part right here same as this part. It makes it congruent. So, therefore, if we imagine that this is a parallelogram, then these two statements here must be equal. So let me set up equation, which is x plus 2 equals 2y. Now, since we already know what x is, let's plug it in. So instead of x, let me go ahead and plus 6. 6 plus 2 gives us 8. A equals 2y. This means I divide 2 on both sides. My y here must be 4. Okay, that solves for my y. Now let's do PQ. And let's look at PQ. PQ is right here. We told that PQ was 3x minus 5. Do we know what x is? Well, we do. So we just plug in. So we do 3 times my x, which is 6, minus 5. This will give me 13 as my value for PQ. Last one, let's look at what's my measurement of PR. We know PR is going to be all the way from here to here. This means my measurement PR will be x plus 2 plus 2y. Since we already know x and y values, we just plug it in. So we have 6 instead of x plus 2 times y, which is 4. And this, using a calculator or solving your heart, that will give you your answer here as 16. Okay, let's look at the next one. Now look at the shape right here. Remember, for these questions like this, you kind of have to imagine it is a parallelogram, and then you solve for the value. That will actually make it a parallelogram, okay? That doesn't fail your, theorems for your parallelogram, okay? So on this one, well, if this is a parallelogram, then this means that this angle and this angle here are consecutive angle, meaning they must sum up to 180 because they are supplementary according to my theorem. So to solve for my x here, I'll just do 2x minus 6 plus x plus 3 equals to 180 degrees. I combine my like terms. This becomes 3x, and this becomes a minus 3, and all of this equals to 180. I'll add 3 on both sides. I'll have 3x left on the left side, and on the other side, I'll have 183. Then I divide 3 on both sides. This will give me x equals 61, and this is going to be my value right here. Then to find my angle measurement of D, right here, actually in a different color, To find my angle measurement of D, there's different ways you can do it. You can either, you know that this angle right here and this angle here adds up together to 180. You can solve it this way. Or I can just use its opposite angle. I know opposite angles have the same angle measurement. So this and this have the same angle measurement. So angle D will also be 2x minus 6. So I will just plug in my x value, which is 61. And the answer I will get here will be 116. Okay, now let's do question C. It says, what's my value of A? Now, if you look at it right here, we know that A plus 18 is actually the same angle measurement as 31 because they're opposite sides, okay? And guys, remember, for all these, we're solving for this variable. Keep in mind that we're treating it as a parallelogram, okay? So, let's set up my equation. So for A, I'll do A plus 18 equals 31. This means I'll subtract 18 on both sides. I'll get my A here as the value of 13. Okay, let's go ahead and erase. And let me fill this out that I know that this right here is going to be 13. Next one, let's try to find my B. Well, I know B here is going to be the same value as 2A because they're opposite sides. So let me set my equation here as B equals to, actually I already have the B here. B equals to 2A. I know A is 13, so let me plug this in, 13. Well, 2 times 13 equals 26, meaning my B here will be 13. My B here will be 26. Now let's look at H. Well, the only two things I can use here, the only two things expression that I have here with H in it is this and this. And what you realize that these two happens to be consecutive angles, meaning they will sum us to 180. So I can set the equation as 2H plus 4H will equals to 180, while 2H plus 4H will be 6H equals 180. I'll divide 6 on both sides, and here my H value will just be 30. And let me circle out the previous ones. And now let's go ahead and do the last one. Okay, now to find my Z, you realize that the only expression with Z in it is just, this lonely Z right here. Now to figure this value out, we can do it both ways. We can do it, we can say that 4H and Z makes 180 together because they're consecutive angles. We can also use that 2H is the same as Z because they're opposite angles. So whatever one you like to use works. Let me just use the opposite ones. So I know Z is equal to 2H because they're opposite angles. And I know H here from previous question was 30. So therefore, my Z is going to be 60 degrees. Okay, now let's move on. Now for question 2 here, example 2 here, you have to draw a picture because the picture is not given to you, and you're going to draw it. So it says A, B, C, and D is a parallelogram. So let me draw it out. Okay, A, B, C, D, with the diagonals. Oops, that's very bad. Okay, now stop here, pause the video, think about what mistake that I made here. Okay, let's see if you got it. The mistake I made here is that if it says parallelogram A, B, C, and D, it says I'm trying to do parallelogram A, B, C, and D, but if you look at my shape here, I have the parallelogram A, B, D, and C, okay? Because if I do A, B, C, and D on my picture right here, it'll be, shaped like A, B, C, and D. It does not connect and make a parallelogram. It has to be in the order for it to be a parallelogram A, B, C, and D. I had to label it as A, B, C, C, and D. This is the correct way that you will label your parallelogram. Just, FYI, this is a very common mistake that some students make. Okay, so let me remake my shape here. This is how you correctly label it. Now, it intersects at the diagonal E, and we're going to use to find the following measurements to find the value of x, okay? Now, we're told here that BE was x. We're told here BC, actually, let me put in a different color. B was x. We're told that BC was 2x minus 3 ED here was 2x minus a, and we know that AE here is x plus 2. Now looking at this, what two expressions here you know that's going to be equal to each other with x in it? It'll be this one right here and this one right here. It's because we know that in a parallelogram, when diagonals bisect each other, this has the same measurement as this has the same measurement as this. So these two are going to be equal. So I will do x equals 2x minus 8. I'll go ahead and subtract 2x from both sides, so therefore I can leave the negative 8 alone. It'll give me negative x on the other side, and on this side here I'll have negative 8. Now I have negative x equals negative 8. Realize that I want my answer as x, not negative. So how can I get rid of the negative? Well, I can multiply both sides by negative 1, because if I do this, a negative times negative makes a positive. So this becomes positive x. And the other one, negative 8 times negative 1, give us a positive 8. And this is how I solve this question right here. Okay, let's do another one. So it says, same shape here. Let me redraw the shape out. Please remember, you do have to draw the shape out whenever you do these questions, or else I don't even see how you can label it. Okay, now it says here that AD was 6x minus 10.5. ED here was 6x minus 7.7. CE here was 2x plus 11.6. And CD here was 6x plus 16. And we're told that DB here, all the way from here to here, was 221. It's asking us to find my value of x. Now, we have to be able to set up equation. Now, you will realize that for this one right here, there's nothing equal to it. For this one right here, there's nothing equal to it. For this one right here, there's nothing equal to it. And the only one we have left is this one and this one. Now, how we can use this to solve for my x? Well, we know that DE here has the same length as EB, right? So we can also know, another way, think about it, we can tell that 2 of DE will actually make 221, because 221 is the whole thing. And we know half of 221 is DE. So we can set up equation as 2 of 6x minus 7.7 will equals to 221. I will go ahead and distribute everything out. This will become 12x minus 15.4 equals to 21. I'll go ahead and add 15.4 on both sides. Oops, I should stop. Give me 12x on the left side. This cancels. On the other side, I have 236.4. Divide both sides by 12. My x value here will be a 19.7. Okay, moving on. Now it says on this one, now on the second page here, it says if a quadrilateral contains any of the following, then the figure is a parallelogram. So in 9.2 and in 9.1 we have learned that if it's a parallelogram, okay, let me write it down. In 9.1 we learned if it's a parallelogram, then it has, two pairs of opposite sides that are parallel. We know that opposite angles are congruent, and there's 2 of them. We know that 2 opposite sides are congruent. We know that consecutive angles, there's more than one, are 180 degrees total. And we also know that diagonals bisect each other. Okay, so yesterday we're given parallelogram, and then we know that these facts are true. Today we're doing the opposite. We're giving a quadrilateral, which is any 4-sided figure, and we're trying to check if any of these met. Then we can tell that's a parallelogram. Okay, so let's look at each of these statements. If a quadrilateral contains 2 sets of parallel lines, then it's going to be a parallelogram. Well, if you look at it, yesterday we did it from parallelogram. We know it's two parallel sides. Today we do the opposite. If we know it's two pairs of parallel lines, then we know it's going to be a parallelogram. Actually, let me do it in a different color. Okay? Same with next one. Well, it says if a quadrilateral has two sets of opposite sides that are congruent, then it's going to be a parallelogram. If you look at yesterday, it's quite similar. Yesterday we say if we have two opposite sides, if we have a parallelogram, we have two opposite sides. Today we're saying if we have two opposite sides, then we have a parallelogram. So it's literally like the opposite. Same with next one. If two sets of opposite angles are congruent, then it's going to be a parallelogram. Well, we have it right here. It's just backwards, right? Next one. Two sets of diagonals side by side each other. Well, same thing right here. It's literally the opposite. Consecutive angles are supplementary. Well, consecutive angles, supplementary. Yes, we have it. The only new one that you have to learn right here is right here, which is that one set of opposite sides that are both parallel and congruent. Basically means if you have a parallelogram, if you have one pair of opposite sides that's both parallel and congruent, then it's also going to be a parallelogram. Other than this statement, the rest is pretty much the same as 9.1. It's just, working backwards. So now let's look at example 3 and determine if these following, shapes are going to be a parallelogram or not. Now, looking at the first one, okay? Now, if you look at it, we're given angles here. And we know that if it's a parallelogram, then its consecutive angles must be 180 degrees. Let's take a look at this one and this one. Does these two adds up to 180 degrees? No. So therefore, it will not be a parallelogram. So I will put no. Okay, for part B here, well, we're giving, diagonals, and we are told that this length and this length are going to be the same length. Okay? Now, with these questions, though, you have to either disapprove one of these to prove that it's not a parallelogram, or you have to, have insufficient information for all of these to prove that this is not a parallelogram. So let's take a look at which one this part B is. The part A here, we disapprove one of them, so make it not a parallelogram. But for part B, let's take a look. Let's check each of them. First of all, do we have two sets of parallel lines? Well, if it doesn't have something like this, then it means no, we don't have two sets of parallel lines. That's the first criteria here. Do we have two sets of opposite sides that are congruent? No, we're not giving any angle measurements, so that's a no. Do we have opposite angles that are congruent? We're not giving any angle measurements. Do we have diagonals that bisect each other? Well, let's take a look at this one. Like I said previously, when you have a parallelogram and your diagonals is bisecting each other, then this means this and this have the same angle measurement, but this also means that this and this also have the same angle measurement, which on this information right here is missing one pair for us. So there's insufficient information to prove this is a parallelogram through this statement right here. So we have to continue check. Okay, next statement. Do we have consecutive angles that are supplementary? No, we don't have any consecutive angles. We don't have any angle measurements. Next one. Do we have a pair of opposite sides that's both parallel and congruent? Well, no, we don't have any parallel sides. So therefore, since we have insufficient enough, we don't have enough information for all these statements, my answer here will be a no. Next one. Let's take a look at this one. Ask yourself, these questions. Do I have two sets of parallel lines? No. Do I have two sets of opposite sides? No, I only have one pair for both of these questions, actually. Do I have two sets of opposite angles? No. Do I have two sets of diagonals that bisect each other? I don't even have diagonals, so no. Do I have consecutive angles that are supplementary? No. And last one. Do I have a pair that's both congruent and parallel? No. So the answer will be no. Okay. Now let's look at the next one. We're actually only gonna go over one very, confusing one, and then we're gonna, not go over the rest because it's kind of the same steps, okay? So let's take a look at this one. Now the biggest mistake made right here is that students be looking at this and like, well, these two adds up to 180, so therefore this is a parallelogram. However, this is not true. If you guys remember with my parallelogram, I have more than one consecutive angle. I have this angle, this angle, they're a consecutive angle. I have this angle, they're a consecutive angle. And so does this and this and this and this. They have to be all 180 for it to be a parallelogram. If you look at your information right here at the bottom, oops, where am I? You realize that I'm only giving one pair. I know they're 180, but I don't know the other pairs, right? So therefore, it will not be congruent to the consecutive angle part. So I know this right here is not true. Okay? If you look at other ones, well, do I have parallel sides? No. Do I have opposite sides are congruent? No. Do I have opposite angles are congruent? Well, I'm not giving any opposite angles right here, so no. Do I have diagonal side bisects? No. Do I have opposite sides that are both parallel and congruent? No. So my answer here will be a no. All the rest will be very similar. Okay? And I'm going to end this video because it's getting very, very long. But I will put an answer here for the other ones. This is going to be a no. This is going to be yes. This is yes. This is yes. And this is no. And please ask me if you have any questions on the rest.